All right, here we go. 12B, we are at the end. This is it, you guys. The light's at the end of the tunnel. Let's charge towards it, all right? 12.5 is all about symmetry, all right? A figure has line symmetry or reflection symmetry if it can be reflected across a line so that the image coincides with the pre-image. Okay, the line of symmetry is also called the axis of symmetry, and it will divide it into two congruent halves. Whatever's on one side has to be congruent to whatever's on the other side. So let's do an example. Tell me whether these figures have line symmetry. If so, draw those lines of symmetry. So this one is clearly a yes, and it actually has tons of lines of symmetry. I've got 1, 2, 3, and 4. But you also have in between 5, 6, 7, 8. 8 lines of symmetry. Craziness. All right, I would like for you to do the next two, so pause me, come back, and then we'll talk about it. Oh, okay, so this one's a big fat no. I cannot draw a line in here so that one side is congruent with the other. This one is a yes. I've got 1, 2, and then 3, 4. 4 lines of symmetry. Rotational symmetry, or a figure has rotational symmetry, or what we call radial symmetry, if it can be rotated about a point by an angle greater than 0, less than 360, so that the image coincides with the pre-image. So this is kind of like this square here. An angle of rotational symmetry is the smallest angle at which you can rotate it and make it look exactly the same. The number of times it rotates is called the order. So let's talk about this. If I give this image, which is a square here, the smallest angle I can turn it to make it look like itself is 90 degrees. This is called the angle of rotational symmetry, 90 degrees. The number of times I can turn it in 360 to make it look like itself, well, 90 goes into 360 4 times. So the order of this figure will be 4. So we're going to try this example. I want to know whether or not this has rotational symmetry, yes or no. And then if so, I want to know the angle of rotational symmetry and the order, please. So if you take a look at the first one, I'm trying to think, if I were to turn this and turn this and turn this and turn this, I don't think I'm ever going to get this image back unless I turn it all the way around. So this does not have rotational symmetry. This next figure does have rotational symmetry. In order to make it look the exact same, I would have to rotate it a whole 180 degrees, right? If I flip this around, it'll look the exact same here. So the angle of rotational symmetry is 180 degrees. And our order, well, how many times does 180 fit into 360? 2. So I can get 2 rotations out of this. I would like for you to pause, please, do this last example, and then we'll talk about it. All right, so this does have rotational symmetry. You'll notice I have to turn it 90 degrees to get back to its original spot. 90 goes into 364, so that means I can get 4 specific 90-degree turns to make it look like this figure. All right, this next one says describe the symmetry and then draw any lines. If there's rotational symmetry, give me the angle and the order. All right, well, this right here, this symmetry is not going to be line symmetry. Right? There is no line that would reflect it across itself. This is actually going to be rotational symmetry. So describe the symmetry. This is rotational symmetry. Okay? I have to rotate it how many degrees to make it look the same? Well, it's 180 degrees. And now not necessarily the colors, just the pattern itself. And then the order is 2. Okay, so pause. I want to know what type or types of symmetry this one has. And then if it has rotational symmetry, I want the angle and the order. Pause and then come back. All right, so this one has both line and rotational. The line symmetry is here. I can't draw all the way down, sorry you guys, here. But I also have at the corners there and there. All right, and it also has rotational. If I rotate this 90 degrees, my order will be 4. Three-dimensional figures also have symmetry, but we call it plane symmetry. Okay, so if a plane can divide the figure into 2 congruent reflective halves, we call it plane symmetry. So if you take a look, I have a rectangular prism here. I slice through with this plane, the orange piece or the pink piece or salmon, whatever the heck color you want to call it, and I end up with two images here that are congruent. This is plane symmetry. It also has symmetry about the axis. Okay? If there's a line in which a figure can be rotated around so that the image coincides with the pre-image, this is called symmetry about the axis. So if you take a look at this cylinder here, the axis in the middle has symmetry around all sides. No matter how I rotate it, I'm going to end up with the same thing around the outsides. So I want to know, does this have plane symmetry, symmetry about the axis, or neither? Well, if you think about it, this first one has both. And I'm going to try and draw. If I draw my plane so that it cuts through like this, okay? If I slice through the top here, slice through halfway, this would give me my plane symmetry. I would end up with a half of a pyramid on one side, half of a pyramid on the other side. I can also put it in axis through the center, and if I rotate it around, I have the same thing on the outside. So this has both plane and about axis. Please pause and see if you can do this one. All right, this one would just have plane symmetry. If I use the plane to slice through in the center here, I would end up with this L image on one side and then a congruent L image on the other side. All right, make sure you guys come to class with questions, and we will talk to you tomorrow. Have a good night.